Hey guys, this is the fourth installment of the Chapter 2 motion series, and as you'll recognize, this is a different background. I'm using the white background because it's easier to draw pictures on. This is a different program actually. So in the last video we talked about something free fall. We talked about an object like this ball here, We talked about an object in free fall going straight down and its acceleration with each passing second, and we learned the equation velocity equals acceleration due to gravity times the time. And we knew from that video, I taught you guys, that acceleration due to gravity here is always equal to 10 meters per second squared, okay? And it's second squared because it is an acceleration quantity. And a few things about acceleration, if you guys forgot, it's a vector and it's change in velocity, okay? Means change in velocity, but go back and watch part 3 of chapter 2 if you don't know that yet, because you need to know it. So now we have this picture. We have this boy here. Let's call it me. This is me, okay? And he has this red ball in his hand and he's standing on this cliff, okay? You do have this diagram in your book, actually, on page 18, I believe, of chapter 2, but I drew it out here so we can kind of work with it and dissect it by ourselves with some help by me. So we have this boy here and he has his red ball and he throws his red ball up, and this path is called a parabolic path. If you know from math, this is a parabola, okay? But here he throws it with such a force that it leaves his hand at 30 meters per second, which is what you see at in this diagram. So right here, the 30 meters per second, that's his instantaneous speed, sorry, at 0 seconds. So then, now as we progress, we want to know, okay, well, what's the velocity at each of these other time intervals? So at the 1 second mark, at the 2 second, the 3 second, 4, on through 7. So we can kind of use what we know here. G is equal to 10 meters per second, and the equation velocity is equal to G times T. So let's go ahead and plug it in. If we go to 1 second and we go V is equal to G times T, well, let's just use intuition, right? And we would know that actually, something even easier is when you're throwing it up. I'm sorry, that was my fault. I started from the wrong foot. When you're throwing it up and it's decelerating, is obviously gravity's trying to pull it downwards, but he's throwing it up, so it's decelerating. And we know that it's decelerating because it's getting slower and slower and slower and slower, okay? Until it reaches the top, then it goes faster and faster and faster and faster, right? So at 1 second, it's simply, very simple, it's going to be 10 meters per second less than this because it's a 1 second time interval. It's a 1 second time interval. So this is 20 meters per second, and then this is 10, right? Now, as we get up to 3, something funny happens. I don't know if you've read this in your book yet, but 10 meters per second, sorry. And then at 3 seconds, it's the top of the parabolic path. It's called the vertex here. And the speed at the vertex, if you guys are in Algebra 2, you probably learned this, but also in physics it applies because the speed at the vertex is always 0 meters per second because it's changing direction. That instantaneous speed right there is 0 meters per second because it's neither going up nor down, really. It's just kind of caught in air for a fraction of a second. So then as it moves down, we apply the same property that we did here, okay? Then it's going to be 10, and then 20, and then 30 here. But now you see these are equal across, right? These are equal. These time intervals, their velocities are equal across, and then we get down to 7, and it's simply 40 meters per second. See how simple that is? Acceleration due to gravity is always 10 meters per second squared. So just keep on going down with 10 meters per second squared because it's change in velocity, change in V, okay? Just keep going down, 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 down. And it's so easy, you could figure out any time interval here. So that's that lesson. Now I'm going to move on to the last section here. Let's work with this black background again, more familiar with. So now we're going to move on to the last one, free fall. How far? How far? We already defined free fall as frictionless falling with gravity only, okay? So that's kind of a rudimentary definition of free fall. So now we want to know, well, how far is something going to go when it's in free fall? So there's basically, we know how to do how fast. We just did that in that diagram and in the last video. So now there's two equations that we do want to look at here, though. I'm sorry, more one that I like because it's more of a universal, which is d is equal to 1/2 g t squared. Okay, and I did put parentheses around the g because the 1/2 applies to the g and the g only. Okay, so now this is the equation to find free fall distance. Okay, and g is often interchanged. You'll see g is often interchanged with a. A being acceleration, g being acceleration due to gravity. Now the reason this is kind of a universal equation is because if you use g, it applies to Earth only, because Earth's gravitational acceleration is 10 meters per second squared. But then you can use this on different planets and just use a and find out their acceleration due to gravity. So like on Mars, I don't know what it is, but on Mars you take its acceleration due to gravity and plug it in for a, right? But here it's really simple. We just want to know the d, right? We just want to know d. So let's say we got this projectile falling here. It's at 0 meters per second here, but what's the distance from here, this 3-second time zone, to here at this 5-second time zone? Okay, so we know that this is 2-second net. Okay, and then we also know that acceleration due to gravity is 10 meters per second. So we can go ahead and plug things in. 1/2 of 10, right? 10 meters per second times t squared. So then, as we move over, I'm sorry, this is getting crowded, but basic arithmetic will tell you that it's 5 times 4, which is also equal to 20 meters. Now, meters are our units here, if we do the unit conversions. So the distance of fall is 20 meters. Now, I know I did this lesson kind of rushed, so the next video we'll be working through examples from the book and from the Think and Explain and the Think and Solve problems in the back of your physics book. But for now, that is the end of Chapter 2, and I'll see you guys later.